All right, let's take a look at some reactions of some thiols. Overall, thiols are good nucleophiles, as we've learned earlier in the semester, when they're deprotonated. And they're not very good bases. So they're much more nucleophilic and less basic than alcohols. So here we can have, for example, a secondary alkyl halide. And if we have some sort of S minus, in this case, I just made it a methyl, but you could make it whatever. It won't do an E2. It'll mostly just do an SN2 reaction. Of course, with SN2 reactions, we're going to get an inversion of the stereochemistry. So if you draw in the same orientation, anything that's a wedge becomes a dash and vice versa. Note that when these thiols have two carbon groups instead of an SH, just like alcohols get called ethers, thiols get called sulfides. So an S with two R groups that are both carbons are called sulfides. Overall, we won't learn too many reactions with sulfides other than their classic SN2 reactivity, which we've seen many times. Just another thing of note is disulfides. So this is where we're going to have a sulfur-sulfur bond and then R groups on either side of it. They're very important in proteins. So when we get to the biochem section of the course, we'll see that. And of course, if you take biochemistry, you'll learn a lot more about this. Cysteine is the amino acid that has a thiol that can be used to form disulfide linkages, which are very important proteins. Your hair has this stuff. That's when you get a perm, you can you mess with the disulfide linkages. Anyways, you've got two thiols. So what you want to do here is you want to add some base, some bromine, and then some water to form your disulfide, right? And again, disulfide is this sulfur-sulfur group where you have alkyl chains on either end, or just carbon chains. Doesn't have to necessarily be alkyl chains. Let's take a look at this mechanism. So first off, we've got one of our thiols and our base. The base is going to go ahead and deprotonate this thiol, which makes it a good nucleophile. Note that it cannot attack the other thiol because the other thiol does not have a good leaving group onto it. So before we can do that, we have to form a good leaving group. So what this S minus does, it attacks a Br2 to attach itself to a Br. Right, so we've got this, and then we've got another negatively charged thiol, attack this sulfur and kick off this bromine in an SN2 type of reaction. And then, of course, that will form our disulfide. So you can do that with this kind of hydroxide, bromine, and water. Sometimes you'll see other oxidants. So we'll just say many oxidants can form disulfides. We won't take a look into those in particular, but if you're interested, Google is your friend. Of course, we can form these disulfides. We can also reduce or break these disulfide bonds. So if we've got a disulfide, if we want to reduce it, we can just add a reductant, something like our zinc in acidic solution, and then we'll get back our thiols. Again, though, in terms of this course, not too common.